Hello, my name is Ryan McKee, and this is my lab report on Lab 1, Charged Tapes. In this lab, I explored the interactions between charged tapes. I tested the tape's interaction with my hand, and then with another charged piece of tape. Then, I measured the maximum distance at which the electrical force of one tape on another was stronger than the gravitational force on one of the tapes. This allowed me to measure the amount of excess charge in a charged piece of tape. I performed this as a physical experiment and then modeled it in GlowScript. This lab helped me explore the principles of charge and the fact that charges cannot be created or destroyed. In this lab, I stuck a piece of tape to the back of another and then ripped them apart to generate a charge on the tape. I found that these tapes, which I called U-tapes, were negative and had an excess charge of 1.269 times 10 to the negative 8 coulombs, or 7.928 times 10 to the 10th extra electrons, a ratio of 3.86 times 10 to the negative 9th extra electrons to every atom. The physics concepts behind this lab were charge attraction and repulsion, and conductors and insulators. Like charges repel, which was central to finding the excess charge. The tape was also an insulator, which helped it retain its charge because the electrons in the tape moved very little. In terms of physical models, Coulomb's law can be used to find the electric force between two charges. This force equaled the force of gravity on the top tape, meaning you could set them equal to each other as shown. Solving for the excess charge gave me the equation at the bottom of the slide. In order to perform this math and model the phenomena in GlowScript, I had to assume the tape was a point charge. This was reasonable because the forces were acting over a relatively small area. Regarding the tape as point charges allowed me to use Coulomb's law. I also had to assume the amount of charge on each piece of tape was the same, which was reasonable because I performed the same actions to charge both pieces of tape, which means roughly the same amount of electrons should have transferred. Finally, I ignored air resistance, which was reasonable because I was only looking at the first moment of movement, which was relatively unaffected by air resistance. I used the physics principles of charge attraction and repulsion and conductors and insulators because they were necessary to perform the experiment. Tape being an insulator allowed it to hold its charge better, as there were no mobile electrons to move the charge. The fact that two tapes with the same charge repelled each other gave me a way to see when the electrical force from the tapes were stronger than the gravitational force. The physical experiment I performed had three parts. First, I created a charged tape and studied how it interacted with my hand. Then, I rubbed a plastic pencil in my hair to create a negative charge. I studied how that charge affected the U-tape. It was repelled by the pencil, meaning that the U-tape had a negative charge. Finally, I made a charged U-tape and placed it on two cups, positioning the cups so that the U-tape had slack. Then, I charged another U-tape and held it under the first one. I measured the maximum distance where the bottom U-tape caused the top U-tape to float, or flip upwards. Here are my results. As you can see, the maximum distance is 3.7 centimeters. After finding the distance, I had to find the amount of excess charge on one of the pieces of tape. To do this, I needed the weight. The piece of tape was around 10.795 centimeters long, and around a meter of tape is 1 gram. This gave me a total weight of around 0.0001 kilograms. Using the equation force of gravity equals mass times 9.8, I found that the magnitude of the gravitational force was 0.00105 newtons. The electric force was equal to the gravitational force in this instance, so it was also 0.00105 newtons. The tape began to float at 0.037 meters. After plugging these numbers into the equation found by setting the gravitational and electrical forces equal, I found that the amount of excess charge was 1.269 times 10 to the negative 8 coulombs. Next, I coded a model of the last part of the experiment on GlowScript. I had already created a function that found the electric field at a point in lab 0, so I converted it to calculate the electric force by adding another factor of q to the equation in the function. Then I created a function that took in the distance the pieces of tape were apart and found the amount of excess charge on one of the pieces of tape. I created this function using the force of gravity equals electric force equation. I also created a visual model in GlowScript using the numbers I calculated. While creating this computer model, I had to assume that the tape was a point charge, that the charges between the tapes were equal, and that air resistance could be ignored. I discussed the reasoning behind these assumptions at the beginning of the video, and they simplified my coding greatly. However, these assumptions caused the coding model to differ from the real-world model, as you can see by how different the visual coding model looks from the real-world model. Next, I considered what the lab would look like if the U-tapes had an opposite charge. I decided that this would not significantly change the results of the lab, as the U-tapes would still have like charges and therefore be repelled. I also considered why it would be important not to handle the tape much. This was important because handling the tape would allow the extra electrons to dissipate, decreasing the excess charge. Finally, I focused on potential sources of error in the lab. Excess charges could be lost in handling the tapes, which could cause them to have uneven or low charges. This could make the distance between the charges become smaller. The measuring was also difficult to do accurately because the movement in the bottom tape as I held it. This could have caused some error in my calculations as well. Finally, the differences in the creation of the tape, like the speed at which I removed it from the table, could have caused differences in each tape's excess charge. Thank you.